survey and its modern technique. In case of modern technique, what we understand, we are doing the work very precisely, but in very short time. In case of modern technique, right now, in survey field, we are using so many things like digital level, total station, GPS, DGPS, uh, your drone, remote sensing, GIS softwares, uh, scanner TS, and also very essential thing right now. Before 3 years, the instrument will come. It is known as leader. This is a very important instrument right now in the field of survey. Okay, right? At first, we are coming to digital level. We are discussing over here about three instruments. Two instrument of a plane survey and another one instrument of geodetic survey. Which instruments we are using over here to give the training to the students? Okay, we are using digital level. Why we are using digital level? That is the main thing, right? I'll come to that topic later. At first, in case of digital level, here you can see two types of stuff over here. One is this stuff is known as scaling stuff, and this stuff is known as barcoded stuff. In case of this instrument, in case of this digital level instrument, we are using this barcoded stuff, and it is of 5 meter height. In case of scaling staff, we have two types of scaling staff. One is of 4 meter and another is of 6 meter. In case of 4 meter staff, or in case of 5 meter staff, or in case of 6 meter staff, every staff has four folds. Okay, and each fold, if we have 4 meter staff, we have each fold of 1 meter. If we have 6 meter staff, each fold have 1.5 meter, and if we have 5 meter staff, each fold have 1.25 meter. Okay. Next, we are coming to that point why we are using digital level in the field. The application of digital automatic levels and impact of the accuracy on the construction measurement. Digital automatic levels are a precise instrument used for precise leveling. Operations of digital level is based on the digital processing of video indication of a coded star at the beginning of the coded star. At the beginning of measurement, a visual pointing of the instrument into the surface of leveling meter is performed. After that, the instrument automatically points the focus of its optical system on the surface of the meter, and then a rough correlation calculation is performed, followed by the precise correlation. According to the data received in the processor of the instrument, an exact distance from the axis of the instrument to the surface of the level meter is calculated. According to the information received by decoding the data from the photoelectric matrix, the height of the level placing is calculated in the processor. During this operation, the coded view of the meter is compared with the information that's saved in the memory of the instrument. Okay. Next, how we can get the setup stability, or how you can set up the instrument. One thing you have to know before doing any type of survey work, at first we have to go to field. Then we are doing a survey that is known as Reiki survey or reconnaissance survey. Okay. In case of reconnaissance survey, we are going to field and see the field condition, field shape, and where we can set up our stations, like that. And after this, after looking to all these things, we are making a sketch. That sketch is known as index sketch. After that thing, we are doing centering and leveling. How can do the centering and leveling? At first, we have to set the instrument on the tripod stand. Okay. Here, in case of level instrument, we are using tripod stand. We are using tripod stand. We are using tripod stand, the aluminum tripod stand. Okay, aluminum tripod stand is a thing, uh, is not such a heavy thing, and we can carry the stand every time. Okay, for this we are using aluminum stand in case of leveling. At first, we have set the tripod legs wide apart to increase the stability of the setup. A setup where one leg is placed on, that is asphalt, and the other two on the soil, will be a stable setup, provided that the tripod legs are set wide enough. If it is not possible to set the tripod legs wide apart due to the obstacle, then the tripod stand can be lowered to increase stability. Okay? Then make sure that all the screws on the tripod or the tri badge are tightened to avoid any play. And any survey quality tripod can be used. However, Spectre Precision strongly recommended the use of tripod heads made of steel, aluminium, or similar material. Tripod heads of fiberglass or other composite material are not recommended. Okay, in this way we can set up the tripod stand. Here we can see two pictures. In one picture you can see the legs are spreaded properly, and in one picture the legs are not spreaded properly. That is not the procedure to set up the instrument. And one more thing, all of you are doing the same mistake. That is in case of leveling of the instrument. You are doing the leveling of that level instrument or any other instrument, the process written in the book, like you put the telescope parallel to 2 foot screws, you are moving the foot screws inward and outward, then uh, rotate the telescope and placed with the perpendicular to this foot screw, and also move the foot screw inward and outward. In this way, you are repeatedly do this thing. Okay, and it will get some 2 to 3 minutes time. It will get 2 to 3 minutes time. And in case of field, when you are going to field, you have to do a leveling of 8 kilometer per day. Okay, and you have to for that thing, you have to say the instrument like 60 or 70 times. If we have set the instrument for 60 times or 70 times, that's mean 60 multiplied by 2. It's mean 120 minutes. 120 minutes mean 2 hours. In a 8 hours of work, you are using 2 hours for doing setup and centering and leveling. You don't have so much time left for doing 8 kilometer of survey work. Okay, you have to give a progress of 8 kilometer every day. For this thing, we are you didn't think that, didn't imagine that it will take just only 30 seconds, just only 30 seconds to do the centering and leveling. Okay, next you can see it is a export leveling data in Excel sheet. From our detail level instrument, we are exporting this data. Okay, we can export this data like that. Okay, and one more thing, I'll show you the exact data when we are doing the survey work with auto level and other instrument. You can have to make this data in this format, and that format I'll show you. The same format will come from our detail level instrument. Okay. And one more thing, why we are using the data level except auto level? Because in case of auto level, we are making the or we are writing the data manually. Okay, and after this, when we are doing the arithmetical check, if we have some error, we'll manipulate that error. But in case of data level, we cannot manipulate that error. Okay, so we are using detail level instrument. We can do four types of work with this level instrument. One is measure, another one is take out, another one is leveling, and another one is ground height and height difference. Okay, I'll show you how we can do the work with ground height and height difference. Ground height or height difference is the same thing. One more thing we have to know, from where do we get the ground height of any point in case of leveling? We are taking MSL to determine any height of any point of the ground point. Everyone will know, or I can say that everyone has this view of where is our MSL right now. Can anyone tell me? You can unmute your mic and tell me where is MSL right now. The heights from there. At first, it is in Pakistan, Karachi. Right now, it is shifted to Nabi Mumbai. This page. Which page, Mr. Shuman Mukherjee? Which page you want to make this zoom? Okay. This page. This is the. We'll zoom this page in this way, or we cannot zoom it more. At first, for making this thing or making this ground height, we are need the RL of that point. We are calculating the RL from we are calculating the RL from BM, or you can say, all of you can say TBM, like temporary benchmark. BM means benchmark. We have four types of benchmark. One is permanent benchmark, one is temporary benchmark, one is arbitrary benchmark, and another is GTS benchmark. GTS benchmark is a benchmark which is established at the time when India is in British rule. Okay, and so every GTS benchmark have a value in FPS system in feet. Okay, and how you can measure this thing? Okay, I will told you. And after switch on the instrument, detail level instrument, we have an option like menu. In menu option, we have a measure. If we enter on measure, then we are going to in measure option we have four modes. One is measure mode, and there is takeout, and there is leveling, and another is GH and HD. We press enter for entering in GH and HD mode. After that, they want if we want to save the data or not. I will press enter to save my data. After that, we have to put the job name. Then we have to put the backside ground height. Backside ground height means backside RL. We will place the backside point. Then we will take the measurement of the backside point. After measurement, they will give two things. One is backside rod height and another is backside distance. Then measuring the foresight point, like foresight rod height and foresight distance, they will give the ground height and height difference of that thing. After doing the work, we'll escape from that and we can switch off the instrument. Okay. In this way, we are doing the survey work with level instrument. The next